Hi, welcome back to the Gapster channel. I'm Gabby, and in this video we're going to show you how you can design this power filter using a very free software and a really inexpensive outfit like a JLCPCB to actually manufacture your own board. I'm going to show you how you can design it, prototype it, get it delivered, and actually use it on a functional project. So what is a power filter, or a CRC filter in this case? It's basically, if you take this i5 power supply, it has like a 5-foot long power cord. So by the time it gets to the DAC in this case, it's just going to be noisy. So if we put some capacitors close to the DAC, it's going to reduce the noise on that line. For example, the Denafrips terminator uses such technique. You can see here a whole bunch of capacitors. Sometimes when they're this close, they're also called decoupling capacitor. So let's build this power CRC filter. First, download this free software called Easy EDA. Link in the description below. Just to go briefly first, what are we building here? So what is a CRC filter and how does it look? What the schematic looks like? So I'm just going to zoom in a little bit. So your power is coming in. So when you plug in your power plug-in, it's going to go from here. And what it does, it's going to first go into an LED light. So just so we know there's power. So just for looks pretty much and for indication. And then you're going to see one capacitor here, just a small one, and another bigger one. The small one will probably be like about 0.1, and the big one is a big capacitor. And this way you're filtering a little bit the power that's coming in. So CRC means, so you've got basically, this is your C, basically your capacitor, and then there's a R, so it's a resistor, and then you have a whole bunch of capacitors after that. And then you've got, so this is what we call CRC. In my case here, we're going to do what we call a CRC-RC, so that's another resistor and basically another capacitor. So that's another resistor and a whole bunch of capacitor, and then it's going to come out from out here. So on the actual board, what does it look like? So it looks like the power is going to go from either the jack or the terminal. You can wire or even solder something. So you have basically three options, and on the other side it's the same thing. So you've got lots of options here. And now some of you may not agree with the schematics or this thing, but don't worry. This is the whole idea about this video is more to teach you how to design your own thing. So whether you like this project or not, it's irrelevant. If I can get you to actually feel confident enough to build something, I would have achieved my mission. So you might not want to do this second part. You might want to just do this part here only, and that is fine. You might choose different value capacitors, different value resistor, and we'll talk about this later. But the whole idea is that you feel comfortable enough that you can actually design something like this, order it. You're going to feel so comfortable you might design something else. Alright, so the first thing you want to do is you're going to start a new project, file new project. We're going to call it CRC filter. I already created one, and here it is. So the first thing you're going to do, you're going to get a sheet called sheet 1, and so this is basically an empty schematic. So, alright, so the first thing you want to do is go to the JLCPCB.com /parts. That's the only way to get in there. They don't have the link directly from Easy EDA anymore, so you have to go separately to it. From here you are going to go into, so we're going to search for a couple of resistors first. So I'm going to go into resistors. I am going to go under surface mount, and from there I'm looking for a 1 ohm resistor. And here's my 1 ohm resistor. We're going to click on that, and I want it to be around 2 watts. So I'm going to go look on the power here, and we're going to go for 2 watts. And we are going to click from here we're going to decide we want to be in stock, and we are going to say apply. And here we go. So we got a list of few basically parts that are available. It's not too many. It's always tough to find parts, and sometimes it says here in stock and you go to actually do it and it's not in stock. So it could be sometimes annoying, but usually eventually you find the right parts. So here we're just gonna click on this one. Seems like there's tons of this one, so that's so this one seems to be more likely to be in stock, so there's a lot of them. So we're going to click on it, and we are going to and here it is, and we're going to copy the JLCPCB parts here. So you want to highlight that code and copy that, and that's all we need from here. You can also go into the specification of the parts. Sometimes there is some specs, sometimes not. I mean, after all, it is a resistor, so there's not a lot you can do. We know it's a thick film resistor, and that's all we need. So we are going to go back to Easy EDA, and from here we're going to go back to Easy EDA. And here we are in Easy EDA. We're going to go into Library, and from here we are going to, in the search button here, we're going to make sure first we have JLCPCB assembled highlighted, because if it's not here you cannot get it assembled. It has to be in here. And we're going to paste that code, and we're going to search, and here it is. I'm going to click on it and make sure it's in stock. And it says here again there's lots of stock, so that's good. So we're going to say place, and what I have to do, you could see now the resistor hovering around. We're just going to say click. We're going to paste one. If you want more than one, you just click again. Here's another one, and when you're done, right click, and that makes it disappear. So now we have two resistors of 1 ohm, and these are 2 watt power rated. So we got our resistors. The next thing we're going to do is find the capacitors and all the rest of the other components. As for capacitors, I spent a long time looking and researching to find something that's decent, that's in stock with a low ESR. The only one I could find that have a decent amount of was this particular one. I'm going to copy that code, and here we are back again to Library. Make sure that's JLCPCB is assembled is selected. We're going to paste the code and search for that, and here it is. And yeah, it says about 2000 in stock. That's it's a surface mount, so that's pretty cool. So we're going to place that. I'm going to need about 9 of those. I'm going to do 1, 2, and 8, 9. And in the same way, a 10K resistor, and we got a diode, couple of terminals, one for the input and one for the output, 2.1 connectors, basically where you plug in your I5 connector that goes into it. There's one at the front and one for the output. If you like, you don't have to have both. Maybe you don't want one on the output, but you can. And we add a couple pads, so you can put wires in case you want to wire those. Once you have all the parts, it's just a matter of organizing them now. So we are going to, for example, if you have a part and you don't like the orientation of it, you just press the space bar and you can turn it around. You just kind of zoom in, see how it turns around. So yeah, so you could turn basically anything around fairly easily. You click on it, you can if you click on it, you can move it around to where you want to put it. So for example, in this case, we're going to put the capacitors this way, like this. So we're going to organize them, and once you organize them, let's just focus on those for a second. Now, if you want to move the sheet a little bit, just right click, you see the hand show up, and now you can move it a little bit. So it make your life easier. So to connect things, you go right in here. It's called in the wiring tools, the very first one. You click on that, and just a matter of connecting. So make sure all the positives are connected to the positives. And then we're going to do it again. We're going to click on the negative to negative. So we're going to connect things together. I'm just going to simplify it first to make it easier for you. So I'm just going to have only 3 capacitors, the LED, resistor, and just a couple pads. So what we need here, we need power. Where is that power going to come from? So we're going to go into the common library. We're going to scroll to the very top. You can see there's a ground here. We're going to click on ground, and we're going to put ground. So let's put the ground down here, and we're going to go to VCC, and we're going to put VCC here. So VCC is like the positive, and ground is negative. So think about it this way. So you can, for example, if you want, you can click on the VCC part, and here on the right hand side you can call it something like VCC, for example 5 to 15 volts. Just out of curiosity, just so something to seem familiar with us. And now we're going to connect things. To connect things, we're going to go into the wiring tool, which is right here. We're going to click on the very first one. We're going to connect ground to this pad, and we're going to connect VCC to this pad. And so now we have positive, we have negative. Now we are going to light this LED when we get power. So I'm going to move this LED. Oh, sorry, we're going to so I did accidentally here because I was still on the wiring tool. If that happens to you, just right click and that goes away. Now you can highlight it and just press delete and it goes away. Otherwise you can also go and click undo. So undo is always a savior for problems. So we're going to move the LED a little bit. I'm going to flip it around a little bit, and I'm going to put the resistor like that, so together. So from the positive here, we're going to go back to our wiring tools, and we're just actually going to highlight those two. If you want to move two things together, you just make a little square around them. So you highlight them, and now you can just move them. So we're just going to put them right in between here, for example. And now we're going to go into our wiring tool, and we're going to go into from the ground. We're going to connect that to here, and we from the positive to here. So look what happened now. We have this LED. It's getting basically power from here and from here, and that LED is going to light up. Now, one thing you need to be aware of is some things have polarity. So for example, the LED, the bar is actually should be connected to ground. So if you have it like this and you finish your project, that LED is not going to light up. Matter of fact, it might even short and burn. So you are going to flip it. To flip it, just press the space bar, and again, and now it's the other way around, and now it should light up. Things like that. Things like capacitors. You do not want to connect the positive pole to the ground. So let's actually connect the capacitors. We're going to connect them this way, and here we go. And for the ground, there we go. So this is one example. I was able to connect power. We have a couple pads, and we can have an LED, and we have capacitors. So that seems pretty straightforward. So the same way we did this small example, we're going to do the bigger example. And here we are again. Now we've got the whole project connected. So I did pretty much what we did in the small example, but on the bigger example. And here we can see we have that terminal one. This is your screw terminals basically. And this is the 2.1 inch, this is a 2.1 millimeter input, the one you plug it in from the iFi, and these are your pads. We'll get to those in a second, but basically it's pretty simple. Here's your screw-in terminal. There's 1 and 2. So 1 is ground, and 1, instead of VCC, we call it V input here. So that's connected to here. And from here, it goes to all the positives of all the capacitors. Now, instead of running ground to all of them, you could actually as long as you put another ground to it, it automatically means it's connected to this ground. So you don't have to keep wiring things to ground all the time. You can just add the symbol ground and that makes it connected. So here in this, so now we have the input terminal, we've got the positive going to the resistor and lighting that LED, and then we've got all the capacitors, a couple of little capacitors first, and then we put our first resistor, a whole bunch of capacitors, another resistor, and a whole bunch of capacitors. Now, this is no longer a CRC filter, it's called the CRC filter, maybe a little bit pushing it too much. And so for that reason, you might decide that, hey, I don't want any resistors, because every time you put a resistor, you're dropping the voltage, you're dropping the amperage. So I would like to leave people the option to maybe not to have two resistors, maybe just one or maybe none. So for that reason, I'm going to add this jumper pin, and you get those from the common library. This is one pin, this is two. We're going to take the two of them, and we're going to put this one here. I'm going to press the space bar to orient it properly. We're going to put one here, and we're going to put one here. And what we're going to do, we're going to wire this jumper pin from here to the resistor. So I messed up a little bit. I'm just going to go and say undo. It's as simple as that. I'm going to start again. Again, click, click, and that's good. Click, click, oh, a little more. And here we go. I'm going to do this one. I'm going to zoom in because I made a mistake here. Something like this could cost you a lot of money and time. You could wait 2-3 weeks. The board comes in. You're like, oh, damn it, it's not connected. So just, you have to double check. Things like that could cost you dearly. So again, I'm going to zoom in on this side and I'm going to move it here. So right click to move. Again, we're going to wire this one. Click. If you zoom in a little bit, it's a little bit easier. Here we go, connected, click, click, and click. So again, why the jumper pins? Because if you decide you no longer want a resistor, you can just put a jumper pin cap here and you have no longer a 1 ohm resistor. And now you have a regular CRC filter, not CRCRC. Or you can put two of the caps here and you no longer have a CRC filter, you just have a filter of a whole bunch of capacitors. And there's nothing wrong with that either. We've also added a couple of small capacitors. Sometimes it's good to have a different size capacitors. They kind of filter different frequencies. So these are going to be 0.1 microfarad. So we put one here, we put one here, and we put one here. So it's 3 of them. And so here you have it. You pretty much have all the schematics done and good to go. Now you'll notice that these are actually not connected here, yet actually they are connected. And how does this happen? The way that happens is that you know that ground automatically connects to ground. So this one is already grounded, connects to ground. This one is grounded, connects to ground. The positive, so if you want to connect other things together without really running lines, you can add what we call net flags. So it's basically the very first one here. So you just add, like here, you just add what we call a net flag. So if you highlight the net flag, see how the name of it, it's called plus V input, and that's very important. If two of them have the same name, means they will be connected together. So this becomes connected to the positive. So that's a positive here going to the input, so that's connected to here. So as soon as we plug in something in that 2.1 connector, it's also going to connect here. It's almost like if we went with this and we went from here and we just connected it there. it has the same value. Now you say, why didn't you do that and make my life easier? I did it because I want you to learn that you can do it in a different way. Sometimes you get so many lines that you have no way to get to it, and you want to be able to use something like that so you don't have to cross too many obstacles. Once you're finished designing your schematics, you're going to save it. I've already done that. Now you're going to say design and convert schematic to PCB. So it's going to give you some options here. You want to choose the start to be at 0. I'll tell you about that a little bit later. And then the width of the board is going to be, in our case, we want it to fit on a Raspberry Pi, so it's going to be 56 millimeters. And the height, it's going to be around 75 millimeters. Whatever height you put here, you just put it up here as well. So the start of the Y will be at that height. We're going to say apply. The reason we did it this way is this way your board outline is going to be right at the 0 marks. So now when you're looking at the grid, you can tell, okay, this is 75 here, and this is 56. So you can tell by looking at the grid how big it is. The other thing you want to do, you want to right click anywhere on the canvas and just say canvas properties, and you want to change the grid size to 1 millimeter. So that's going to be 1 millimeter, and the snap size we're going to change it to 0.1 millimeter, and we're going to say update. And what happens is now we can actually say that from here till here it's 75. You can see that it's 75. So the number starts to make sense. So they're not just arbitrary numbers, and we know where everything goes into place. And here you're going to start by basically grabbing your components and putting them where they should be. We know we have a 2.1 connector here. We're going to take the other one. Now see how this one's facing the wrong way? You're just going to, same like with the other one, click on the space bar, and now you can orient it the opposite way. And you're just going to keep moving your parts. This is your terminal. Again, we're going to change it to where it should be, and then we're going to put it right here, and keep going till you use up all your parts here. In order to make things a little easier, I decided to change the name of those couple of components. For example, in here, instead of saying U1, you click on the resistor, and where you see on the right here on top, it says prefix, it says U1. You can change the name. We're going to call this one R1. You see how now that changed. Here it is, that changed. I've already changed this one to R2 and this one to R3. And this way I know roughly where things are. And then we're going to say save, and you're going to say design, and you're going to say update PCB. It tells you we're going to change a couple things, and you can just say OK. You can temporarily disable the grids, and I'll show you why. So if we take the grid out, things becomes a little more clear. You can start to see a little bit more. And then when you come to fine-tune things, then you can put the grid back on. For example, we know that in our case here, C4 will need to be close to the LED here. Because if we go look at the schematics, we can see that C4 belongs before the R1. So you've got C4 and that's 0.1, which is C1. Those two belong together. And then you gotta get the two banks of capacitors after R1 and R2. So after R1, we're gonna have 5, 6, 7, and 8 capacitors, and then 9, 10, 11, and 12. And this information is gonna come very handy. So when we go here to look at how we're going to put things, we're going to put 4 here separately, and then we're going to do 5, and we're going to flip those so to be on the opposite source. At the end we can put the ground all in the same direction in the middle, and we're going to just move for now just C2 and C3 just a little bit to the top here. We're going to put these are holes. You can get them from this part here, and this is to actually mount the PCB. So we're just going to move them a little bit for now to the corners. We'll decide a little bit later where to put them. Maybe we're going to move this one down a bit. Actually, I can just see that happening. And then we can put that here, same with this guy here. There you go. Something like that. And we're going to put the hole here. Okay. So the way you add holes, like I said, you click on here and then you just click here. That's all you have to do. And then in the parameters, you can decide what size you want the hole and how big you want it to be. But we just don't want it now. We're just going to delete it. There you go. So we got here C5. I'm going to C6, C7, and C8. We have those on this side. And then on the other side, we're going to have C9, C10, 11, and 12. So now we get a little bit of, we're starting to see a little bit of sanity here into our design. That doesn't mean it's perfect, but at least we've got a little bit of a starting point. We're just going to move we just still have to move the terminals and the pads to the right places as well. Since we've done some improvement here, we're going to just press save just so we don't lose everything sometime in case of a crash or internet goes down. So just to give us a little bit of a safety net here. So I've got all the components here organized. Now what we're going to do is we're going to go say route and say auto route. What does routing mean? It's just going to do all the connections for you so everything gets connected. And just make sure it says here cloud, so means you're relying on the auto router from JLCPCB in the cloud, and that's fine. And we're going to say run. And it's just going to go and just going to tell you at the end, it says 50% attempted, 50% completed. Make sure there is nothing failed. And that's very important. And then you are going to press OK. And here you can see that the software made all our routing for us and connected all the parts together. And if you click, for example, on the +5 here, you could +15, you could see that that actually connects I added 4 pads because I don't want the holes, if someone's screwing in that board, to connect it to ground in any way, in case the paint of the board and the screw touches it. So I created a pad this way, there's a little bit safety, and these are going to be connected to nothing. And in order to connect something to nothing, what you want to do, you're going to bring the nothing here, not connected flag, and you just click like this. And what you want to do, you're going to do a little bit of wiring tool from here to here. And then after that, you're going to go get the not connected flag. So no connect flag. You're going to click on that and you're going to put an X on this. Otherwise, the software is going to be wondering where the hell are these things going. And this tells the software that these are not connected to anything. We are going to save our project. And we're going to say design update PCB. So here are the 4 pads that we just created. So what we want to do is we want to take those holes out. So you highlight them, you press delete, simple as that. And instead, we are going, not sure what that is, just going to delete that. We're going to take the pads, we're going to put them in the four corners. So these are like the mounting holes, is basically what they're going to end up being. So it's going to be here, and it's going to be here. Now remember how we put our axis here at 0? So we are going to put this guy here. If you look at, no, that's fine. Now, for the mounting holes to coincide with the Raspberry Pi, they need to be about 49 apart millimeters this way and 58 this way. There is a measuring tool, so you can actually use it. You can click on measure, click from here, click from here. So we are at 46.4, so we need about 3 millimeters more. This is when the grid could come in handy. So we are actually going to say view grid. And this way we can actually move things a little bit more in a more precise manner. So we're just going to put this guy, let's put a little more here, and this guy will be more here. It's going to measure again. Sure, there's a better way to do this, but I'm just going to do it the way I know it. So this is, we're at 47.6. We need 2 more millimeters. So I know each grid is 1, so that's 1. And let's move this guy a little one from here. Measure. That's and here we are, we have 49 millimeters. Now they are good. We're going to add 4 basically holes. So we're going to select the pads here because we want some copper around them just so they are isolated. I'm going to put 1 here, 2, 3, and 4. So you could do it like this and then edit each one separately, or you can actually highlight all 4. And here we can edit them. So we want how wide they are. So we want them to be quite wide. So say 6 millimeters. And we want them to be round and not rectangular. So it's actually oval. So we want them to be round. And we want a hole inside them. So for that, it's going to be next thing I would like to do is add 4 holes to the board that are padded. So I have some really nice holes that I usually like to use. So I'm going to go into library and we're going to paste this word. So it's hole, so just the way you see it here, D3M5, and you just say search. And make sure you're into the user contributed part here, because otherwise you won't see anything. And what you want to pick is the very first one, I believe, that is highlighted here. And you could see it, that's a picture of it, so it looks nice. It's got some nice things around it. And we're going to say place, so we're going to put 4 of those. So 1, 2, 3, and 4. And these should, let's just move them a little bit so they're a little bit easier to see. And if you don't want to see that big long description, you can click on the component and just say where it says display name, just say no, and it just it just does that. You can also say display prefix, also no. And I just rearrange them a little bit better. And what you need to do is these can be connected to a certain like ground or positive. And what you want to do is you don't want to connect them to anything. So you go here and there's a next, and this is called no connect flag. So you click on that and you basically X each one of them. So basically you're telling the software these are not going to be connected to anything. So don't worry and don't give me any error. And don't give me any errors. So now that we've done this, we're going to save the file and then we're going to update the PCB. We're going to say design, update PCB, and we're going to say OK. It's going to be adding those, say yes, apply the changes. Here you can see them. That's what I'm talking about. They kind of look cool. So we're going to put one here. They're quite big, and that's OK. Oops. I'll tell you how we're going to get rid of those names too as well. So just put them here for now, just so it'll be a little bit easier. You can click on that 3.5 millimeter part. You can delete that. No. Okay. So here we go. And so just going to make a little bit of room for these guys so we can put them in. After doing the first prototype, I did another one and I did a few changes. I added a couple capacitors, there was a little bit of room there. And that makes it 10 capacitors in CRC mode. And that means 2 microohms of ESR. And then I changed the jumpers because there were female jumpers instead of male jumpers. I reshuffled some of the parts around and squeezed them a little bit because I want the board to fit under the two TD1 shields, and this way it will be all part of the system. It'll squeeze nicely in there and it won't be dangling outside. So I also have a bit of extra room and I squeezed a couple more capacitors in here. As you can see, if I go into my schematics, I added a couple more capacitors on the second bank here, and just since we have the room, why not? And that will reduce the SR and all that kind of stuff. So the other thing I need to do now is, in order for this thing to fit under the shield, I'll have to trim the board outline so it actually can squeeze in and it doesn't impede on the rest of the parts. So we're going to do that now. From time to time, it's pretty cool to click onto the 3D model. And this actually gives you how the board is going to look like. And this is actually good to be able to visualize it and see what's going on, see how the layout is going to go. And you can see here how sometimes you could see like the plus and the minus are not lined up properly. You're going to have to fix that a little bit. You know, you can start to see minor things. These are a little bit shoved into in here. You're going to move them around. Maybe this guy's too close, you know, stuff like that, and see if we can make it a little bit better. It is really important to, when you're labeling things positive and negative, to make sure you're actually labeling it correctly. I've done mistakes before in the past, and I've learned my lesson. So for example, when you put your mouse on the ground, on the negative, that should be connected to ground, and that it is connected to ground. So we know that the label is correct. And let's check here. This is the plus, and this is the ground. And that is correct as well. So just always important to check things out. So I moved the plus and minus like we said. I noticed there is no markings here on this terminal. So what we're going to do, we're going to copy plus and minus. You can also create new ones, but it's easier to just cut and paste. Copy and paste. So here we have plus and minus. Now, again, let's double check these are correct. So this should be ground. And so it's the other way around. So we're going to flip them around. And this is, so it's going to be negative. So it's going to be positive. Just going to double check one more time. And that is correct. And we move those around. Let's again check back into 3D and see if it looks any better. So yeah, you could see we got the plus and minus here, the input here, plus and minus here. We still have a couple things like, I don't know if you really wanna, yeah, and plus I'm probably gonna get rid of that U1 here. I don't really need to see that. And maybe organize the C1 and the R3 so they look a little nicer, just center things around a bit. Also notice there's no output, there's an input, there's one that's still hiding somewhere here. Just gonna bring it back out and just make it a little bigger. You can change the font size by here. So when you click on it, it says, usually it's the height that kind of helps a lot. So instead of 1.2, I'm gonna go with 2.5. And now it just says output. So we know it's our output. Now it's kind of probably upside down in case you're looking from this angle. So we're gonna go and just turn it around, and now it should say properly output. Now we know that that's the input, that's the output. Might as well maybe center them both together so they kind of look about roughly the same. Same idea basically where they are right here. Here we go. And again, we look again in 3D, just have a quick look. So you can see we clean this up, fix the CRC, maybe I'll put the C1 on top, and all that. Anyway, you get the idea. After looking at the space it's going to go into, I decided to trim some of the board parts to fit some of the UFL connectors and not to impede on the PSM board. So what I did, you can actually click on the outline and you could see all these dots. You can actually move those dots around and just play with it till you actually get it the way you want it. Now you can see if I click on the 3D and you can see the outline of the board. You can see how it's cut off here, and that's going to allow it to fit properly. There's also a small cutout here as well. So this gets you really to really visualize how everything is going to fit together at the end. For example, this terminal is recessed a little bit towards the back, same as the output here, in case you when you wanna run so this way when you're running the wire to the out part, you don't have to go outside too much and stick out, because that's the front of the DAC. So you can actually route it within here and probably loop this here and keep it going with discreetly without showing too much. So the last thing you want to do is you want to go into Design Manager and check that there are no DRC errors. You can click on the refresh here and that there are no nets error. You might also want to go back one more time and check your schematics. Any problems with the schematics will transfer to the actual final work. So you want to just zoom in like really close and have a good look, make sure all the connections are connected. Sometimes there's one that's just a little bit short and just enough to mess up a whole project like that. The last thing you want to do, you're going to go back to your PCB and make sure you save that. And what you want to do is you want to go into fabrication and you want to actually generate the Gerber file. So you do that. It says check DRC, yes. And here it is. I'm just going to say generate Gerber file, and we are going to put it into and we are just going to put it in a new folder here. So we're going to create And we're going to call it Gerber. We're going to call it Gapster Power CRC filter for now. I might change that name later. And we're going to save that Gerber file. And we're going to go back one more time. We're going to do the pick and place file. And just say export. There's nothing to do here. And we're just going to say save that. And that's going as well in the same place. If you want, you can also do the pick. If you want, you can also, and if you want, you can also do the build of material file and just say export. And we're just going to save that as well. So now you've got those three files. Now we can go ahead and order our PCB. Now, if you like to improve your design a little bit, you can go into design rule. And it was set initially at 0.8, then I changed to 1.2, but I'm going to do it to the max that I could actually figure out I could do it. I'm going to do 1.6. I'm going to go apply, settings. I'm going to go route, auto route. And just make sure nothing fails. So nothing failed. I've tried more than 1.6 and things start failing. So that's the maximum width we can do. The last thing you want to do is you want to do your copper pour. So you see how it's all just traces, but there is no copper that's, for example, holding all of the ground and all that stuff. So what we're going to do, we're going to start with we're going to go on this part here, and it says, instead of all, we're going to click on copper. We're going to see where the pencil is basically where things are happening. So on the, we're going to go on the blue, which is the bottom. And so that means if the pencil is on the blue, means you're designing the bottom part. So now you're going to go into here where it says copper area. We're going to click on that. And what net do you want to? We want this to be ground. So we're going to say ground. And I'm going to go, I'm just going to trace just a little square from here to here to here. You can go around just like we doing with everything here. And at the end, you just right click. And automatically you filled everything with a copper, so everything is nice and the grounds are really nicely done. So now we're going to switch to the top layer, and I am going to do the exact same thing. I'm going to go again, and again it's going to be ground as well. And we're going to go same thing. And here we go, and we've got our ground pour. So now we are all good to go. Now we can, if we're going to save that, if you want, just to be sure, you can do one more auto route. Sometimes things change a little bit, but everything looks good. Now we're good. Check the DRC, and that's good. So we're all good to go. From here on, I made a special video on how to actually order it from JLCPCB. It will be in the top corner here after at the end. And so just follow that video, and that should get you to order your own PCB. I'm also going to put on my Patreon link all the files from the Easy EDA files if you would like to actually use them to modify the schematics. For some of you may want like a good head start, so this way you get all the schematics and all the configuration files. You can actually download those into your Easy EDA program and actually modify them, and this way you don't have to start from scratch, or you can just do the whole thing. So it gives you some flexibility. It all doesn't cost you much. It's just $1 to join, and basically you'll help supporting the channel at the same time. I'm going to put in the this corner here a video about how you can actually order the CRC filter from JLCPCB. And in the corner here, I'm going to put a list of 10 holographic songs that you can listen to on your system and make you understand a little bit better how 3D imaging works and how other things work as well. There will be a speaker in the middle if you'd like to join my Patreon for as little as $1 to support the channel, and that would really help me a lot. And you can also subscribe. Also, that doesn't cost you anything. It will help the channel as well. I hope to see you again, so take care.